Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we will be discussing about the methods of river training. Now, in the previous lectures, we have discussed about the different problems that occurs during the flow of the river, and to ensure that the river flows in the designated path with the certain amount of velocity and with certain amount of discharge, certain provision need to be done. And to install that provision, that cumulates to form a term called as river training. Basically, we are training the river to behave in a certain way. That is, we ensure that the river flows in a designated path with a certain minimum depth of flow, with a certain velocity, and with certain discharge. And we have discussed about the this in the previous lectures. And then we have also discussed about the objective of river training and how it is achieved. This lecture, we are going to discuss about the methods or the structures that are used to ensure that the river flows in the designated path. Okay, so if you haven't watched those videos, I highly recommend to go and watch the videos. If yes, then we can continue with the this methods of river training work topic. Now, from the previous lecture, we can summarize that the ultimate aim of the river training work is to achieve the ultimate stability. This means that the river again flows in the designated path with a certain depth of flow, certain velocity, and certain discharge. Now, how do we achieve that? We achieve that by constructing certain structures along the river. What are those structures? The structures can be by construction of marginal embankments or leaves, by construction of guide banks, by construction of groynes, also called as spurs, by artificial cutoffs, by pitching the bank, and by construction of launching aprons, by construction of pitching island, and then case-specific miscellaneous methods can be installed in the river to ensure ultimate stability over the flow of the river. Now let us discuss each of these in detail. So the first one is the marginal embankment, also called as leaves. Now these marginal embankments are nothing but the earth embankment that are basically constructed at the both side of the river. Now these are constructed so as to ensure that the erosion from the side slope is avoided. Okay, so what happens is that we can see that the side slope of the river is made up of earth soil, right? And as and when right now in this picture you can see that the water is fairly calm, but maybe due to uh, a seasonal rainfall, the flow of the depth of flow of the water may increase, right? The depth of flow of water may increase, and the velocity with which the water moves is also increased. Now, in such scenario, when the flow of water is very high, it may happen that the portion of the side slope may get eroded. So, to ensure that this erosion is controlled and the stability of the river bank is achieved, what we do is we pitch the side slope of the river, right? And these are what we call as the marginal embankments or leaves, right? These are the so here this is what we call as the marginal embankment. Okay, these are what we call as the marginal embankments, and these ensure that even at a higher flow of the river, the side slope of the river remains safe from this, and there is no silting phenomena occurring. Okay, so if this is a recurring interval, then you can see in this image here that the part of the bank of the river has completely washed out, right? And this causes instability in the river channel. So to avoid that, what we do is we pitch this with leaves, or also called as the marginal embankment. Now, depending upon the scenario to scenario, here in this picture you can see only part of the river bank is being pitched with the leaves or the marginal embankments. But in case if the flow of the river in general is very high, like in this picture, the flow of the river is very calm, right? And maybe in a seasonal rainfall, the flow increases and then the erosion may take place. So in those scenario, the impact is not that disastrous. So a part of the river bank is being pitched with the marginal embankments. But in case where this phenomenon is very frequent, then whole of the river bank basically being covered with the marginal embankment. And in more severe scenarios, the side slope or the bank of the river are covered with concrete, are covered or lined with concrete so as to avoid complete silting of the side slopes. Okay, so this is your first way of ensuring that the silting from the river bank is avoided by construction of marginal banks. They can be installed partially depending upon the scenario to scenario, or to along the full length of the river. Then the second type of river training work structure is what we call as the guide bank. Okay, now guide banks are the structures that are used to confine the flow of the river. Okay, these are used to confine the flow of the river. So when a weir or a barrage or a bridge is constructed across the river width is reduced and trained to ensure safe and expeditious disposal of floodwater. Okay, so basically what happens is here in this image, this is what we call as the guide bank. This is what we call as the guide bank. Now, if this is the flow of the river is flowing like this. Okay, so by construction of marginal bunds or marginal embankments, we first of all confine the flow of the water, and then the water is forced to move in a certain confined path. Water is forced to move in a certain confined path. That is, we are guiding the water to move in a designated path. Okay, so for that, what we use is what we call as the guide bank. These are what we call as the guide bank. These are the guide banks. Okay, so these are used to confine the flow of the water to ensure safe and proper disposal of flood water. It has a reasonable width of to ensure that the water flows. Okay, it's not like it's not like we by our own priority can reduce the flow of the water. If we do so, then you see this is the original flow of the water. This is the original flow of the water, and if we reduce the width too much, then the water will not be retained in this structure, right? So in a so we have to be reasonable to ensure that the flow of the water is maintained. These are generally provided in pairs, as you can see in the image here. These are provided in pairs. These are symmetrical in nature. Both are having same dimension, normally constructed from the same material, and may either be kept parallel or may diverge slightly upstream. Okay, so depending upon the scenario to scenario, if the river flow is very high, so they can be constructed like this. They can be constructed like this, but generally, this is they are constructed in a parallel way. Okay, so these are your guide bands. Here in this image, though it is not much clear because the image is taken from the front, but this is what we call as the guide band. Next river training structure is what we call as the spur, or commonly known as the Groynes. Okay, so see what happens is we have a river, right, and the water flows in the river with certain velocity. So the moving water impacts the bank of the river with certain velocity. Okay, it keeps on striking the bank of the river with certain velocity. Now, what happens is if the banks of the river are not pitched, if these are not pitched, then what happens is this moving water will eventually lead to small amount of silting down the during the certain time period. Okay, so to ensure the stability of the bank, we construct certain structures, what we call as the Groynes. Groynes are basically embankment type structure constructed transversed to the river flow, extending from bank to the river. Okay, so basically these are structures that are constructed transverse against the flow of the river, and they extend from the bank of the river to inside the river. And the purpose is to protect the bank, and the nose of the grounds are the one that take most of the impact. Okay, so this is an example of grounds. This is an example of grounds. So what happens is that as the water moves, right? If the water is moving like this, if the water is moving like this, so the flowing water will strike the nose of the ground, and the velocity with which the velocity with which the water is moving, it will, once it strikes the ground, it will reduce. Okay, it will reduce. So, so first of all, what will happen is the water is moving like this. It will strike the nose of the ground. With the velocity will reduce. Again, the water is moving. Water is moving. Again, it strike another ground. The velocity will be again reduced, and like this, the process keeps on going. Now, with this, what happens is the since by the regular decrease of velocity of the water, what will happen is the velocity with which the water strikes the bank is very less. Okay, so the silting, the probability of silting reduces to a very greater extent. Okay, so this is one image that shows the construction of Groynes being taking place, and as we have discussed initially, that they extend from the bank of the river to the inside of the river, or to the middle width of the river. Like we can see here, it extends from the bank of the river into the river. Okay. Then down the line, of course, as we have discussed, that the nose, this part is what we call as the nose of the grounds. This part, okay, this whole structure is what we call as grounds. This part is what we call as the nose of the grounds, and this is the part of the ground that takes the most of the impact. So down the line, the grounds also get destroyed. So constant repairing of the grounds is a need, and you can see in this image here, good number of grounds being constructed so as to ensure the velocity of the water is reduced, and and the banks are preserved. Okay, now you can very well appreciate, like if we had gone for the construction of marginal embankment, you can see the how much expenditure we would have incurred. Okay, if you see, if you would have constructed marginal embankment throughout the length of the river, then the cost of construction would have been very high. Instead, what we have done is we have constructed along the flow, against the flow of the river. We have constructed these grounds. So these grounds has reduced the flow or the velocity of flow of the water, which in turn has protected the bank. Okay, but marginal embankment has their own usage, right? In case where the velocity is very high, or to protect the bank from the seasonal heavy flow of rainfall, then definitely we have to go for the construction of marginal embankments or leaves. Okay, this is again an image that shows the construction of Groynes. Now talking about the alignment of Groynes, like type of Groynes in term, if you talk about the type of Groynes, the subcategory can be characterized on the basis of type of alignment. In this type of alignment, we have the first type of grounds called as ordinary grounds. And ordinary grounds are the one which are perpendicular to the bank line. And these are also called as normal grounds and are used in the convex bank. Okay, so if this is, let's say a left bank, this is your right bank, this is the grounds, and water moves from here, from the upstream to downstream. And as it moves, the ordinary grounds is perpendicular to the bank line, and as the water moves, it strikes the nose. Ripples are, whatever ripples need to be formed will form there, and as the water moves from here, the velocity is reduced, and as the water moves ahead towards the downstream, it moves with a reduced velocity. Then we have the repelling grounds, and repelling grounds are the ones that repels the flow of the water, and these are created along the upstream side of the river. Okay, these are created along the upstream side of the river. As we can see, like this is the upstream side. So along the upstream side, the direction will be along the upstream side, and angle is around 10 to 30 degree with the normal of the bank. This is the normal of the bank. So at an angle of 10 to 30 degree, these type of grounds are constructed along the bank of the river. Now, as the water comes with a with certain velocity, the it strikes the grounds, the velocity is reduced, and then it moves. Now, what happens is that moving water always contains certain amount of silt particles. So this moving water, when it strikes the nose of the ground, the velocity is reduced. So definitely, once the velocity is reduced, then what will happen is there will be certain pockets of silt will be deposited along the bottom of the ground. Okay, this will happen because the velocity is reduced. Now the flow of the water is not strong enough to carry the silt particles. So these silt particles, silt pockets are being observed to be deposited uh, along the bottom of the grounds. Okay, and definitely there are a lot of score holes that are created along the nose, and these are mostly used along the concave bank and. The repelling grounds, if the length is somewhat smaller, then these are what we call as the deflecting grounds. Okay, if we see in this image here, you can, if we look in this image carefully, you can see if this is the flow of the river, if the water flows from here, this is the upstream side, and the water goes like here, this is the downstream side, and the water strikes here, so, along the nose, and so you can see the patches of silt pockets that are stored right here. You can see likewise, like here also you can see. Okay, so this is what the repelling ion does. Then we have attracting ions, and these are usually constructed just for the safety measure. The flow of the water is not that high, but just to ensure safety, what we do is we create and attracting ions, and these are created along the downstream. Okay, so this is your upstream, this will be your downstream. The angle of inclination will be 60 to 80 degree. Okay, so this is your attracting ground. They attract towards the bank. Score holes are developed near the bank opening for the damage. Okay, so these are usually constructed when the velocity is the velocity is somewhat low. It moves with a very small velocity. The water is moving with a smaller velocity, so that even if the water is attracted towards the bank, it strikes with a much lesser velocity. Okay. Then talking about the length of the ground, talking about the length of the grounds, the length depends upon the position of the existing bank line. If we construct too long, then this bank become very easily erodable. If it is too short, the whole of the purpose of installation of ground becomes ineffective. What does this mean? Let's see. If let's say this is the bank of the river, and we have constructed one ground. Okay, and if we are constructing very long ground, right? If you are constructing very long ground, so what will happen is the water will come, and it will strike the grounds. So the impact this ground will face will be very high, and it becomes easily erodable. It becomes easily erodable. While while if we create very small gryon, then what will happen is basically it won't serve any purpose. The purpose of installation of smaller gryons will become ineffective, and water will move. There will be negligible reduction in the velocity, and the impact that flowing water will have on the bank will remain the same. Thus, the bank will erode. Okay, so if we construct too long gryon, the gryon becomes very prone to erosion. If we construct too short gryon, the purpose of installation of gryon becomes ineffective. So um, the best practice is having the combination of long and short. Okay, so we'll start with the short length, and then we will extend gradually. This is the best practice that is followed. Talking about the spacing between the gryons, so the governing factor is first of all the length of the gryon, then the type of bank in which the gryons needs to be constructed. So for the convex bank, we have large spacing for 2 to 2.5 for convex banks, and the spacing is equals to length of gryon for concave bank. Then the third factor is the width of river, and river of equal discharge will basically require large spacing for wide river than the narrow river. Type of ground for permeable grounds we will require higher spacing. Permeable means the grounds that are constructed of simply soil. Okay, so in that case we require somewhat higher spacing. Okay, then the next category of to assess the type of ground is based upon the material for construction. Okay, so in this, the first one is impermeable grounds, which are also called as embankment grounds. These are made up of rockfill embankment, earthen embankment, or armored embankment. Armored embankment will be multi-layered. That is, the inner part may be made up of soil. Then we'll cover the soil with the lining of concrete, and then we will cover it with patch of stones. Okay, the head especially is protected by the stone pitching and concrete blocks, so as to ensure that the impact of flowing water is properly resisted. Then we have the permeable ground, which permits the somewhat partial flow of the water through them. And these are basically the temporary structures. Common materials that are used are tree, timber, stone fill, soil, like that. And they do not act as a serious obstruction. And just we want that very intense eddies and scoring of the bank do not take place. Okay, these are very cheap to construct, and when these are submerged, then there is no strong turbulence. However, they promote silting, right? They promote silting. Why they promote silting? Because see, these are made up of what? Made up of soil only. Okay, so as the water moves, they will eventually will dissolve get dissolved with the moving water down the line, right? During after a certain period of time. So what will happen is this will dispose into soil particles along the bank of the river. Okay, depending upon the flow of the river, maybe right at that point or maybe after some duration of the point. Okay, that is why they promote silting. These are the example of your temporary grounds. You can see these are made up of soil, and over that trees and plantation is done so as to ensure that there is no immediate erosion. Okay, these are not that strong, but does serve the purpose. Then the third is what we call as the T-shaped grounds, and these are, as the name suggests, are T-shaped. And these are like somewhat special type, not found everywhere. Usually was developed, these are developed in India, and basically the nose is somewhat T-shaped so as to resist more impact, of the nose resist more impact of the flow of the water, and these are usually spaced 800 apart, right? So this larger arm, you can see these are these arm are not evenly distributed, right? We have shorter hair and longer hair, right? So this longer is placed against the upstream so as to resist, give a better resistance toward the flow of the water. Then we have hockey shape grounds. Again, the shape is like hockey, and these exert an attracting type of influence on the flow, hence not useful for repelling the current away. Okay, again, these are usually constructed, right, where the flow of water is very less, and just for the safety precaution, we construct like this. These are more of a attracting type of grounds. They attract the flow of water towards the bank. Okay. Next, the next type of river training structure is what we call as the artificial cutoff. Now, about the cutoff we have discussed before in our previous lecture. So you can refer the basics about the cutoffs in that video lecture. The link I will put in the comment section and the description box as well as in the cue card here. Okay, so basically what happens is that down the line the lot of meandering, because of too much meandering, what happens is too much silting and scoring takes place and the river changes course. Now either the cutoff can be made naturally. In case the cutoff, like you can see here, the cutoff is made naturally, right? You can see down the line, the cutoff is made naturally, and then the river changes its course. You can see this point, this area. Here the cutoff is being made naturally by the flow of the water. But in case there is too much silting taking place. However, no natural cutoff is being done. So in that scenario, what we do is we create an artificial cutoff so as to ensure the flow of water along the river continues. Okay, so when this cutoff is done manually. This is what we call as the artificial cutoffs. Okay, when meander goes on increasing to a extent that it pose danger to the neighboring land, river course strengthened through artificial cutoff. Only pilot channel is required, having erodible bed excavation. Flood water gradually enlarges the pilot cut. Pilot cut should be as deep as possible. Alignment of cut should be tangential to the main direction of flow, and supplementary river training work may also be required. Okay, so basically, what does this mean is that uh, when there is too much silting of the river bed, Either the artificial cutoff happens naturally, but if this the flow of water is not sufficient enough, or if we require the result immediately, okay, suppose there is some habitat area along the river, or some construction is being proposed in the nearby area, or over the river, then to ensure that the river flow remains the same, what we do is we uh, create an artificial cutoff. We will cut along the section so that the flow of the river continues and the river moves in a designated path. Now we have to ensure the cut is deep and very precise. Why? Because if it is not done in a proper way, then what will happen is the alignment of the river down the line may change. Okay, because if the banks are cut in a very uneven and in a very improper way, then down the line the erosion silting scoring will take place, and the river may change its course from here. It may change its course to like this. Okay, and then some additional measures like construction of marginal embankments, construction of grounds may also be required so as to ensure that the flow of the river is maintained. Okay, so this portion is the example of cutoff. You can see this is happening naturally. If done manually, this is called as the artificial cutoff. Okay, and usually it is done along the tangential flow of the river. You can see naturally also it happens like that only. So manually when it is done along the tangential flow of the river. Next, we have the river training work that we are going to discuss is the pitching of bank or the provision of the launching apron. Now, what happens is that definitely by construction of marginal embankments, we are able to we are able to protect the banks of the river. But usually, if the problem is more severe, right? If the problem is more severe, this means along the banks of the river, the bed slope, the erosion at the bed slope is also taking place. Okay, so in that case, what we do is we not only pitch the bank of the river but also the toe of the river. Okay, what we do is we not only pitch the bank of the river. Here we can see we have pitched the bank of the river, and along the bank of the river we have pitched the toe of the river. Okay, so in case there is too much erosion at the toe level, right at the toe level of the river. So if what would have happened is this is the flow depth. Okay, this is the flow depth. This is the flow depth, and the erosion is taking place right at the toe of the river at the bed slope. So in that case, to protect this, what we do is we create a launching apron. Okay, so it looks something like this. Okay, so this is what we do. This is your conventional pitching, and then this is your launching apron, right at the toe of the river, so that this part of the toe of the bank of the river is also protected. Now, see what will happen if we are not constructing the launching apron. What will happen is, though we have pitched the side slope, but the erosion will take place from from the toe of the river. Here also, the erosion or scouring is taking place. So eventually, what will happen is, if we are not having any launching apron, the moving water will erode, will score the bed slope right at the toe, right? It will score, and down the line, this scoring will keep on increasing, keep on increasing, and it will go like this, right? It will keep on increasing, which will once it goes like this pitching will slide down into the river. Okay, so the whole purpose of pitching will also fail. So in order to ensure that the whole of the bank is safe, what we do is along with the pitching, we create a launching apron. Okay, so this used for the protection of the toe of the river, and the stones in the apron has to launch into the deepest score, like what till the point where the scoring is taking place. Slope 2 is to 1, average thickness 1.25 times the thickness of the pitching provided at the bank. Okay, thus deepest score may be taken equals to x times the leases residence score depth, and varies from this x varies from 1 to 2.5 or 3 of the from the depending on scenario. To be put into the simplest term, to the point we see that the scoring will take place, right? That wherever at the toe the scoring is taking place, we extend to that plus few more length. Okay, this is if we put it in the simplest term. Okay, Then next we have is what we call as the pitching island. Now you see in the launching apron, what we have done is we have protected the toe. But sometime it may happen right at the middle of the river bed, the scoring is taking place. Okay, right at the middle, not at the. I'll just show you by figure. If this is our irrigation canal, this is the side slope, right? And we have created a launching apron like this. We have created a launching apron like this, right? And this is right at the toe of the river, where up to which the launching apron has been created. Okay, this is by doing so, what we are doing is we are protecting this side. Okay, and the water is flowing seamlessly along the bed slope. But like it varies from condition to condition. Sometimes some scenario may arise that here the scoring is not that much. However, right at the middle, that too in a certain spot. So if we look into the channel from the top, right at the certain level, we are having too much scoring pockets, at certain pockets of the river, right? If you're looking from the top, okay, this is like this it will look. So that area so instead of lining whole of the irrigation canal, so see all these things depends upon the type, the amount of budget that you are having and type of irrigation canal that you have. Okay, so if the budget does, if the budget permits, we can fully line the bed slope with concrete. That is, but that is a expensive scenario. Okay, so to in order to do the same thing economically, what we do is we create certain wherever there is too much scoring, we pitch that portion. Basically, we pitch that portion, and that is what we call as the pitching island. Okay, only that part is pitched. So that is what we call as the pitching island. These are artificially constructed islands in the riverbed and is to protect the stone pitching from all sides. These because of the turbulence generated by the island, river channel around the island get deepens, attracting river toward itself and holding it permanently. Okay. Then the last is the miscellaneous method that I used for the river trading work, and in this, the first one is the submerged dike, and the next is your closing dikes. So these are like case specific, right? It is not uniform. These are case specific. The submerged dikes are used in special situation. Sometimes the river sometimes create deep channels in the vicinity of certain pakka structures and require correction. So in that scenarios, we create these submerged dikes. Closing dikes are used to close particular flow so that the river may be directed to the another desired direction. So just to change the flow of the river temporarily, we create the closing dikes. Okay, so these are certain structures by which the river is trained to behave in a desired way. Okay, so this is all about the river training structure, and through this we have completed our topic over the river training works. Okay, I hope the lecture was this lecture as well as the series of river training work was helpful to you. If so, do like the video and comment your views in the comment section. Tell what improvement you require or how if you found the lecture useful or not, and if there is any scope of improvement, do let us know. And then if you are a regular viewer of the video of the channel, or you can check out the other videos, and if you feel that channel is somewhat useful to you, then do subscribe to the channel and share the video. That's it. Thank you for watching. Have a nice day.